how do we convert out something where I have units both upstairs and downstairs? So as an example, what if I want to change 165 pounds per square inch to instead being expressed in terms of kilograms per square centimeter? So in those ones, we have both units in the numerator and the denominator. So on the given information, the 165 pounds per square inch, when you hit the word per, that is the information in the denominator. So this would be 165 pounds, it would be in the numerator, and in the denominator you have 1 square inch. So in the denominator, instead of just putting 1 like we have been, we'll have 1 and we'll have some units down there as well. So I've got two things I need to do. I need to convert my pounds to kilograms, and I need to convert my square inches to square centimeters. Now it doesn't really matter which one you do first, we're going to have to do both of them eventually. I'm going to convert out my numerator first, and then we're going to convert out the denominator second, right? Just because I have to make a choice and we have to get started somehow. Now I want to get out of pounds, so I'm going to put that on the diagonal of where it is currently occurring, which is, since pounds was in the numerator, on my conversion factor is going to be in the denominator. Now, do I know a relationship between pounds, which is what I'm in, and kilograms, which is what I want to go to? And yes, I have a conversion factor for that. I know that there are 2.2046 pounds in 1 kilogram. Okay, so I'm going to use that for my conversion factor. The pounds information will cancel along the diagonal, and right now the units I have left are kilograms, which is what I want, so I'm good there. Now let's convert out the denominator information. We want to go from square inches to square centimeters. Right now, because inches is in the denominator, in order to convert it out, in order to put it on the diagonal, when I've set up my conversion factors, I'm going to need to put the inch information in the numerator. It's got to be on the diagonal of where it's occurring. And because I'm trying to convert out square inches, I'm actually going to set up two fractions where the inch information is in the numerator. Now I'm going to ask myself if I know a relationship between inches, which is what I'm in, and centimeters, which is what I want to go to. And the relationship is there's 2.54 centimeters in 1 inch. So next to my inch labels, I'm going to put 1, and in the denominator, I'm going to put my 2.54 centimeters. Now, because I'm not trying to just convert out from inches to centimeters, but square inches to square centimeters, that's why we're going to do that fraction twice. Now my square inches are going to cancel with the inch information in the numerator, and if we look at what's left, I have centimeters, but it's in the denominator, so I'll have square centimeters in the denominator, which is exactly what I want to have in my new units. So we're good there. I now have what units I want in both upstairs and downstairs, so now we're just going to do some computations. So upstairs I have 165 times 1 times 1 times 1, or it's just 165. Downstairs I have 2.2046 times 2.54 times 2.54. We need to be a little bit careful about computing that all at once. If you do just compute the denominator in and of itself, don't drop any of your decimal points. So when I pop that in my calculator, I got 14.22319736, and that should be good enough for right now. But don't round these too early. So that's what I got just by multiplying the downstairs elements. So then you get my final answer. We'll do 165 divided by this 14.223193736 number, and I got 11.6007. There was some more stuff after that, but if I'm trying to take this to 3 significant digits, my final answer would be 11.6, and my units are kilograms per square centimeter. Alright, so these are obviously a little bit more challenging because you have two sets of units you have to convert out. So let's maybe try this one more time. Let's change 65 miles per hour to meters per second. So again, where you hit the word per is where the fraction bar is. Whatever units are behind that line are what's in the denominator. So this would be 65 miles, and then my fraction bar in the denominator will have 1 hour. We ultimately need to convert miles to meters and hours to seconds. I'm going to convert out the denominator first, just to show you that eventually you have to do both, and it doesn't really matter which one you convert out. So if I want to convert out hours first, and I want to get from hours to seconds, now if you happen to know how many seconds there are in an hour, great, go ahead and use that. But I don't know that off the top of my head. What I do know about hours is that there are 60 minutes in an hour. So I'm going to go ahead and use that. So hours are going to go on the diagonal of where they are, because in the original fraction they're a denominator. When I build my conversion factor, my hours are going to be in the numerator. And the relationship I know is that 1 hour has 60 minutes. Now at this point in time, the hours will cancel, but my units are in terms of minutes. And I don't want minutes, I want seconds. So I'm going to set up another conversion factor. Minutes will go on the diagonal of where it is, which is going to be in the numerator of this new fraction. And the relationship between minutes and seconds is that in 1 minute there are 60 seconds. Now my minutes information will cancel. My units that I have are seconds, which is what I want. And notice that they're in the denominator, so that looks good. I'm done with my time conversion. Now let's go ahead and convert out my miles to meters. Okay, so my miles have to go on the diagonal of where it is. And if you happen to know how many meters there are in a mile, you can use that right away. But one of the factors, if you've been watching some of the other videos, that I happen to know for my length conversions between my US customary and my metric system is there's 0.9144 meters in 1 yard. Okay, that's the piece of information I'm working with. So how can I use that? Well, all right, so I'm going to have to get my miles in terms of yards, and then I'll be able to use this factor. Now, if you happen to know how many yards there are in a mile, great. I don't happen to know that, but I do know that there are 5,280 feet in a mile, and I know the relationship of yards to feet, so I'm going to use that. So in 1 mile, there are 5,280 feet. Okay, so my miles will cancel on the diagonal, but the units right now I'm in are feet. So I want to eventually get this to yards. So then the relationship is there's 3 feet to 1 yard. The feet information are going to cancel along the diagonal. And now I can use my conversion factor is in 1 yard. There is 0.9144 meters. My yards information will cancel along the diagonal. The units I'm left with are meters, which is what I want, so I'm good there. Alright, so here we go. What we have to do to figure out the numerical part of my final answer is 65 times 1 times 1 times 5,280 times 1 times 0.9144. That's just the numerator. So if you pop that in your calculator, verify for me that you get 313,822.08. In the denominator, you really have 1 times 60 times 60 times 1 times 3 times 1. Popping that in your calculator, you should be getting 10,800. So then if we take this and divide this new numerator by this new denominator, I got 29.0576, and there was some more stuff after that. But I want to keep this to 3 significant digits, so I'll keep the 2 and the 9. And then after my decimal point, because the 5 is 5 or bigger, I'll round the next number up, so that 0 will jump up to a 1. And then my units on my final answer are meters per second. Okay, so I had to use what I knew along the way. I had to set up maybe a couple of factors when I didn't know a direct relationship in order to get me to the units I wanted to go to. And this one we had to know the relationship of miles to feet in order to get feet to yards in order to use this conversion factor that I knew. These ones definitely take a little bit of practice and to make sure that your units are on the right part of the fraction bar. I want you to notice as I've been working through these that I pay a lot of attention to where the units are and make sure my units cancel the way that I want them to before I start doing the numerical conversions. Because if your units aren't going to be correct, we don't want to do a bunch of calculations that are not going to give us what we want. Also notice that I never stopped along the way. Like for instance, I didn't stop after I got to seconds and then just converted that. I built up a series of fractions, converting out everybody, so I knew exactly what I needed to do in all my numerator calculations and in all my denominator calculations before I started actually computing some stuff.